All right, we're ready to start putting numbers with our formulas, okay? We're going to talk about formula mass. We're going to talk about the mole concept. Now, some of you learned about moles in high school and you're starting to break out in a sweat, okay? We're going to be able to tackle this. I know we are. But what we need to do is we need to review some of the things that we've already talked about with regard to atoms and elements and apply them to compounds, okay? So let's think about section 2.9. We talked about atomic mass. We learned that the AMU system is based upon carbon-12 and that one carbon-12 atom weighs 12 AMUs. We know that when we go to the periodic table and look up any of the elements, we can know the average mass of the isotopes. So when we look at carbon, okay, while 1 mole of carbon-12 would be 12 grams, if it was the, we're just up on the scale from atomic mass to molar mass, so we're still talking about carbon-12. If we had 1 mole of carbon-12, and see that 12 with the C there? I probably ought to write on the screen. My little superscript is gone, so that's a 12 superscript there. So 1 mole of carbon-12 would have a mass of 12 grams. So that's the molar mass world. So we can talk about it in terms of atomic mass or we can talk about it in terms of molar mass. That's what we learned in 2.9. Now we're going to do the same thing but for compounds, okay? When we're dealing with compounds, we talk about formula mass. And we could talk about the formula mass as being the sum of all the atomic masses of all of the atoms within that formula. Whether that formula is a molecular formula or it's an ionic compound, so we have to use an empirical formula. And when we talk about formula mass, we're generally talking about it in the AMU world. So we're talking about the mass of 1 molecule. We're talking about the mass of 1 formula unit in units of AMU. But we could up that scale and we could talk about, don't want to up the scale yet. Sorry, we want to do an example. Barium chloride has 1 barium. A barium has a mass off the periodic table of 137 AMUs. And there are 2 chlorine atoms, so it would be 2 times 35.45. It says 35.5 because I didn't carry as many significant figures. So if I add those together, I will get a formula mass of barium chloride of 208 AMUs. Now, barium chloride is an ionic compound. Therefore, I'm not saying a molecule of barium chloride has a mass of 208 AMUs. I'm saying 1 formula unit, which consists of a barium and 2 fluorides, or 2 chlorides, 1 formula unit has a mass of 208 AMUs. But we don't work with individual molecules or individual formula units very often. We're dealing with enough that we can hold and see and feel, so we usually work in the scale of grams where we can actually measure the mass. So we will take and we will up the scale to work with masses in the gram world, and that would be molar masses. Okay, so we could talk about the molar mass of a compound as opposed to the formula mass. Now what's the difference? Well, we're in the world of grams. So a whole mole of barium chloride formula units, take a whole mole of those, and it's going to have a mass of 208 grams. So we've just upped the scale. Another way we could write that is we could say that it has 208 grams per mole. Per mole of what? Per mole of barium chloride. So formula mass versus molar mass is just a difference on, are we talking about an individual formula unit or an individual molecule? That would be the mass in AMU units. Or are we talking about a whole mole of them, and that would be the mass in grams. Okay, so now we've got a bunch of tools. I want you to consider doing chemistry and doing these problems as me teaching you a bunch of tools, and your job is to figure out which tool you're going to pick out of your arsenal and use. So we've been developing these tools. Some of these we've been using along the way, back in Chapter 2. We learned to go between grams and moles for elements in Chapter 2. We can do the exact same thing here with compounds and go between grams and moles, and anytime I know grams of something, I can get moles of that same thing by knowing its molar mass, and we go to the periodic table to get that. We learned about a mole in Avogadro's number in Chapter 2. We can apply the same thing here. In Chapter 2, we said, well, I could have a mole of iron atoms, which would be Avogadro's number of iron atoms. in this chapter, we could talk about a mole of molecules. I have a mole of water molecules. That would be Avogadro's number, 6.022 times 10 to the 23rd water molecules. Okay. The third one is density. That's a tool that we learned in chapter 1, where we can go between grams and volume, or mass and volume, between grams and milliliters or grams and cubic centimeters, and that's density. We learned all of our prefixes, and you're not allowed to forget those. So there was a table full of prefixes. That kilo means 1,000, and micro means 10 to the minus 6. So you have those memorized and what they mean, and we'll be using that tool. We're going to add a new tool here, and that is to go between molecules and the atoms in a molecule. And to do that, we use the subscripts. Okay, so let's just think about that for just a moment here. Let us say we have 2 molecules of water. Since that's a molecular compound, okay, I've had 2 molecules of water. I could ask you, how many hydrogen atoms does that have? Okay, now you could in your mind envision 2 water molecules, HOH, HOH, there's 2 molecules, okay, so there's 4 hydrogen atoms, and then you've got your answer. There are 4 atoms of hydrogen. But I want you to think about this in terms of dimensional analysis and this tool that I have. The tool says to use subscripts to get between the atoms and the molecules. So, how would we do this? We have 2 molecules of water, and we're doing dimensional analysis. We say, well, I don't want molecules of water. The question is asking how many atoms of hydrogen is that? And it says I will use a subscript to do that. So when I look at this and I see the subscript 2, I know there are 2 atoms of hydrogen in every molecule. So then the molecules cancel, and I am left with 4 atoms of hydrogen. Now you might think, well, that's a ridiculous thing to do, all that work when I can just know off the top of my head that there's 4 atoms in there. All well and good, but when you're doing a whole series of things and you start dealing with weird numbers and weird formulas, it's handy to know this little tool. Now you don't have to do this tool in the world of individual molecules. You can use this tool in the world of a bunch of them and get in the world of moles instead. We could have 2 moles of water molecules. Okay, and we could ask the question, well, how many moles of hydrogen atoms would be in there? So we would do the same thing. I don't want moles of water. I want moles of hydrogen. All I've done is up the scale, talking about the compound versus the element in the compound, and there would be 2 of those in one of these. So you can use this tool, and that would of course give me 4 moles of hydrogen. We can use this tool there in that world as well. So you can be down on the individual number of molecules world and use the subscript tool, or you could be in the world of, I've got a bunch of them, how much do I have 2 moles? How much is that? 2 times Avogadro's number, okay, a bunch of those. And I want to know how many hydrogen atoms. I would use the subscripts. So anytime you're going between this compound, and it says molecule there, but it could be any compound, and the atoms in it, then you would use that. Now I'm going to step over there and write on my screen for just a minute, because it might not be molecules, it might be formula units, okay? Because that's the word that we use when we are dealing with our ionic compounds. Now, look down at the bottom. We've got this little flow chart. If you know how many grams of something you have, you can go to moles. And how would you do that? Well, you would use its molar mass, so we see that underneath it for carbon dioxide. If you wanted to go from moles to molecules, you could do that using Avogadro's number. And if you went from molecules to atoms within the molecule, okay, then that's where you would use the subscript street. Now, all of those arrows that I see there are pointing to the right, but there's nothing that prevents us from moving to the left. So we could go across in the opposite direction, and we let our units do our work for us, figuring out how to put down what we need and cancel what we do not need. So here's an example problem. Okay, how many hydrogen atoms are in 5 grams of water? And we're going to work through this problem. But what I want you to do is I want you to stop the video and I want you to answer this question. I want you to plan your strategy. Now, how are you going to plan this strategy? Okay, don't try to answer it yet. How you plan this strategy is to look at the tools available to you. So flip back in your notes and look at those tools and say, how could I tack these tools together to build the answer that I'm looking for? Stop and select one of those answers, and when you have one, resume the video. Okay, now if I were to solve this problem, I could get to the answer in one of two ways correctly. I could either go the route of B, that would be using tools correctly. Okay, whoops, sorry. Where'd it go? I gotta get there, sorry. Here we go. Okay, I could get there by doing B, going from grams to moles to atoms. Or I could do E. If you picked either one of these, that would be fine ways to get to your answer. But let's work through it, and I'm going to choose one way or the other. I'm going to choose E as my way of getting to the answer. Okay, so let's see if we can do this together. You start by writing what's given to us, and we were given that we have 5 grams of what? Water. Okay, so we're in the grams of water. And the first thing that I know I can do is to go from grams of water to moles of water. I can go from grams of water to moles of water by going to the periodic table and getting the molar masses of each of those elements. There's 2 hydrogens and there's an oxygen. And when I take those 2 hydrogens and an oxygen, I'm going to get 18.02 grams in a mole. So we would always have the number with the gram. And you will always have a 1 with a mole, because that's the definition of molar mass. It's the mass of 1 mole of this substance, by definition. So there we go. Now that would be going from grams to moles. Now we're going to go from moles of water to molecules. Now there's no good abbreviation for molecule, so I'll do MOLEC of water. Now moles is like a dozen. If I have 3 dozen eggs, I have 3 dozen eggs, but if I said how many eggs is that, you would do 36, okay, right? Well, moles is like that term dozen, meaning it's 12, but moles doesn't mean 12, it means a lot more than that, and it's so big that I can't fit it on that blank. 6.022 times 10 to the 23rd molecules. So now I have got my way going from grams to moles, from moles to molecules. At this point I know how many molecules of water I have. But that's not what was asked. We have one more step and I can't fit it there, so I will keep it going down here. I don't want molecules of water. What it's asking me for is atoms of hydrogen. And here is that tool that we learned up here. Every molecule has 2 hydrogen atoms. So now we're ready to put that into our calculator and get a value for this. Now all you have to do is everything that's on the top, hit the times button. So it's 5, and everything on the bottom you hit divide. So 5 divided by 18.02, then times, make sure you use your exponent key, 6 times 10 to the 23rd, and then multiply by 2, and you have 3.34 times 10 to the 23rd atoms, okay, of our hydrogen. Now if you put that in your calculator and you did not get that answer, you need to come and see me. You need to come and see me and see, how do I use my calculator correctly? If you have any questions right now how to use that calculator correctly, especially with regard to putting this number into your calculator, please come see me and get that straightened out now, so that I don't see next semester you still putting it into your calculator incorrectly. Okay, I think that is, double check, we did that. Okay, so yeah, that's the last example problem I'm going to do here with you, where we've used each of the tools that I expect you to know, or this new one dealing with subscripts. We used these tools when we were in chapter 2. We're going to practice this a whole lot in class with a lot of within your groups. Okay, so be expecting that.